Good evening, ladies and gentlemen. After having the first two lectures on the challenges, the problems, and last week the science, David Reay, who's going to be speaking this evening, I'm very pleased to say, is focusing more on the solutions. Now at Edinburgh, we're extraordinarily fortunate right across the university to have world-leading researchers and lecturers and tutors in this field, in the wide range of fields addressed by Our Changing World series. Tonight's speaker is somebody who's started life as a marine scientist, looking at work in the Antarctic, and has looked at further at work on soil and carbon emissions. Since he joined the university and was promoted to senior lecturer, he's now leading the MSc, the master's course in carbon management, a world first. I think the fact that we've got queues of students coming for this postgraduate course, capped at just under 50 for the last 3 years now, is testament to the university standing, but also the way we've been able to blend both geosciences, in this case, and the business school. And so I'm looking forward to what Dave's going to share with us. Dave.
Thanks, David. Can you all hear me all right? At the back? Wait, yep, you're nodding. Fantastic. I just need to load up my presentation. Just to comment on the carbon management programme, which I direct. So I know a couple of the current carbon masters are here tonight, and you'll see at the end a video that the carbon masters from last year made for Copenhagen, which is something which was, I think, a fantastic contribution, but we'll see what you think. For the next 45 minutes or so, though, I want to concentrate on what it says up here, the solutions in terms of climate change. We hear a lot about, you know, oh, what a problem it is. We wring our hands, I guess, in terms of political inaction and, you know, the various scenarios we're shown. But actually, what I hope I can give you all tonight, hopefully you can take away, is some of the real opportunities we've got for tackling climate change, some of the real success stories that we've already got, and a real, from my point of view, reason to be optimistic in terms of facing this particular challenge. So to start off with a bit of history, a bit of context, I'm going to put up, asked if I could include lots of science, so I am going to not shy away from the science tonight, but I'm really going to focus on two areas in terms of the solutions. One, adaptation, so actually dealing with the climate change which is already happening and making ourselves more resilient to future climate change, and mitigation, dealing with greenhouse gas emissions in the main, so how we can avoid the kind of scenarios that we hear about in terms of the coming century and negative impacts of climate change. In the context of where we are, this figure kind of says everything to me as a greenhouse gas scientist. What we've got here is the Keeling curve. So Charles David Keeling, 1958, knew that we were burning lots of fossil fuel, knew that that had carbon in it, it was emitting carbon dioxide, and he argued that we should be measuring carbon dioxide in the atmosphere to see how it was changing. So he set up a monitoring station on Mauna Loa, a dormant volcano in Hawaii, very high up, brilliant for measuring carbon dioxide. It's a very long-lived greenhouse gas because there are no big point sources. So he could basically get an index of how much carbon dioxide was across the whole northern hemisphere. Since Dave Keeling started measuring carbon dioxide, we've had an expansion of these monitoring networks. So now we've got a global network telling us what the concentration is. And it's quite a beautiful graph for climate scientists, for biologists, because the red wavy line there is the natural cyclical changes in carbon dioxide in the atmosphere. It's the seasonality. So basically we have the drawdown in the spring and the summer in the northern hemisphere because plants are growing. The oceans are taking up more carbon dioxide. So you see that down curve there. And then as we get into the northern hemisphere, autumn and winter, we see the plants shutting down, senescing, the carbon dioxide concentrations rising back up. So it's quite a beautiful thing. The sinister thing behind it is that every year it returns to a higher concentration of carbon dioxide. So this is global CO2. So basically you've got these steps, this increase in carbon dioxide, which over that kind of time scale, so over here, 2006, this was downloaded a couple of days ago, so very up to date in terms of how much CO2 there is in the atmosphere. That kind of change is kind of worrying, but over 5 years, you know, we really wouldn't be that concerned. But we've seen this change all the way back to when Dave Keeling started measuring carbon dioxide, and through ice core records, etc. We know the levels of carbon dioxide in the atmosphere are higher than at any other time in terms of human history, so for hundreds of thousands of years. If we then go to 2007, the fourth assessment report from the Intergovernmental Panel on Climate Change, this was the kind of figure which came out of that report, a synthesis of the climate science, basically a message to policymakers that depending on the decisions human civilization takes, human society takes, we could end up with various scenarios in terms of the amount of warming we see, the change in global average temperature across the planet. So you can see the different coloured lines are basically different ways our society will react in terms of economic development, greenhouse gas emissions, and the warming which would result. So we had these clear messages, and this was the fourth assessment report, so we'd had many years of climate change science saying, you know, this is potentially a very negative result for humankind, we should be doing something about it. And so in terms of the solutions, we often look to these kind of events. So these people down at the bottom right, this is Copenhagen. Now for most of us, we were on the top left there, so we were outside, freezing cold, ironically, queuing up to get in to actually see what was going on, see what negotiations were moving forward. The great hope was that we would get some kind of global framework to listen to the science, to fit with the 2-degree post-industrial warming, which is the aim in terms of the scientific recommendation and the one adopted by politicians, where we need to cut emissions so we don't pass that line in the sand, as it were. The outcome, as we all know, wasn't what many had hoped for. Copenhagen didn't deliver a global agreement in terms of cutting emissions to the extent that the science suggests is required. We had the Copenhagen Accord, which had some good things in it in terms of financing for adaptation, and we had a lot of argument. And so Cancun, which is the next big climate change meeting at the end of this year, we're back to a position of will it deliver a global agreement or not? And I'll come back to this political solution. But political solutions in terms of what's in that office and kind of saying, well, if they haven't solved it, then we're stuffed, is really not looking into the truth of the matter and what's available and still the potential we've got to cut emissions to tackle climate change. So that's what I'm going to cover now. First of all, in terms of adaptation. So like I said, this is dealing with climate change or severe weather events or just the outside in a more resilient way. So for Maddie here, when she was, I think she was about 1.5 there, she was adapting to the fact that we were on holiday in Scotland, like we always are in the summer, and it was, as you can see, not the best weather. So she's adapted by wearing wellies, I think they're on the wrong feet, and by having waterproofs on. Today she adapts by seeing what kind of mood I'm in, and if I'm in a good mood, she asks for pocket money. If I'm in a bad mood, she goes somewhere else. That's adaptation. But in the context of climate change, we've got some fantastic precedent for how well we adapt to climate change. Climate has always changed. Climate didn't start changing as soon as human beings started burning fossil fuels. We've always had climate change, we've always had variations in weather, severe weather events, and our species is arguably the most successful species ever to live on this planet. So we've got great experience of adaptation. A great example for me is recently DFID, our Department for International Development, went to Bangladesh and they were doing a fact-finding tour and they were talking to people dealing with frequent flooding in the Sundarbans. And They were talking about how our solutions could be provided to them. How can we help you with your flooding? Should we build you a big wall? We've got the Thames Barrage, we're very proud of it. Maybe we could get investment for that. And what came back was, well, that would be nice, but actually one of the problems we get is because of the flooding, you know, we can't raise chickens. So could you give us some money for ducks? Now that is real good adaptation. That is good thinking, and that is where a lot of the adaptation policy is learning to actually talk to people who know about dealing with weather variations, with the impacts of climate change. Another great example, one of the ones which my carbon masters are familiar with, are camelones. And this again is a technique for essentially adapting to a changing climate. So you find these in Bolivia now, but it was essentially a forgotten technique. It dates back to about 1000 BC. And essentially what you've got, if I had my Al Gore platform, I'd reach up to the top. But essentially what you've got is a rainy season and a dry season. And if you've got your normal agricultural land, in the rainy season, if you've got the water lying on the surface, your crops die, so you can't grow then. In the dry season, and the water's leached away, it's taking nutrients with it, and it's very hard to grow crops then. So the camelones were just a system of canals, which have been instigated, so that when it's rainy, you've still got raised areas of soil, so you can still grow your crop, and when it's dry, you've still got water conserved and nutrients conserved, which can feed your crop. So essentially, you can produce more per unit area. A real simple adaptation strategy, which has had great benefits in terms of not just producing more food, but because of that, reducing pressure on deforestation, helping in terms of preventing leaching, increasing crop yields. So in terms of adaptation, I haven't got time to go through all the good examples, but there are many examples, like I say, through not just recent history, but through all of human history of how we've adapted to changes in climate. The area I'm really going to concentrate on, though, this evening is mitigation. And most of you, all of you, will be familiar with the different ways we can produce energy, some of them high emitting in terms of greenhouse gases, some of them low emitting. So I'm going to go through some of them and then go into a section on geoengineering. So first of all, in terms of mitigation, if we want to reduce the amount of greenhouse gas, the amount of carbon dioxide in the atmosphere, there's essentially, through human activity, two categories we can use. On the right there, the circled bit, is burning fossil fuels. We can limit how much carbon ends up in the atmosphere as carbon dioxide through either burning less fossil fuels, using carbon capture and storage, those kind of technologies. Or over on the left, we can change our land use practice. We have a lot of deforestation still, obviously, which means that carbon ends up in the atmosphere which wouldn't otherwise, and so we can use that as a mechanism to manipulate how much carbon dioxide there is in the atmosphere, enhancing global warming. If we look at where to aim our policy, and we look at a figure like this, which is from the International Energy Agency, and it's looking at the growth globally in the amount of carbon dioxide per year from these different sources. So the one that stands out immediately, and it's in red, is electricity generation. We want more electricity. We've got an increasing population, as Paul talked about in the first week of these talks. People want light like this. They want computers. We want more electricity, and at the moment that often means burning more fossil fuel. So in terms of where we direct our mitigation policy, our solution, then that's an obvious target. If we look at how we do that, again, there are many solutions available to us, and some which we've already had a lot of experience in through economic drivers rather than climate change. So here we've got an example of essentially the evolution of conventional electricity production from what you would class as your dirty old coal-fired power station to something which is much more efficient. So you're getting much more electricity for the amount of carbon dioxide you put into the atmosphere. Other options like nuclear, so although nuclear isn't carbon-free as such in terms of uranium enrichment, much lower carbon emissions. So these are kind of traditional sources of electricity which we can put into the mix as a solution in terms of CO2 emissions. The other side to this, obviously, is carbon capture and storage. Really big hope for Scotland. Hopefully it will produce as much economic gain for Scotland as North Sea oil and gas did. It would be beautiful in many ways if we end up putting as much CO2 back under the North Sea as we produced by getting the coal, oil and gas out of it in the first place. But the technology we know works. We need to now demonstrate it on full scale. But the idea would be that, yes, we've got coal, we've got oil, we've got gas. We can't expect growing economies like China and India not to burn their reserves. We can't even expect the UK not to look at using its coal reserve. So if it's going to use those fossil fuels, is there a technology in the form of carbon capture and storage where we can take the CO2 emitted, or most of it, and put it back out of the atmosphere, so prevent the CO2 concentration in the atmosphere rising? Another solution. I suppose Scotland is a perfect place for this, because I talked about carbon capture and storage being a big hope for us. The other great thing we've got going for us is a lot of coastline, big tidal ranges, and it's pretty windy. So in terms of renewables, this is a nation which is blessed, and that is why we're seeing a rapid expansion in terms of investment in renewables in Scotland and the UK. But obviously these forms of renewable energy, solar panels down the bottom here, I've got them all over my house, but I must admit, having had a fantastic summer with them a few weeks ago, they kind of crashed in terms of their output, and I imagine they won't murmur again until about March. It's not a brilliant place for photovoltaic cells. But for wind, for tidal energy, there's a lot of electricity to be produced in a low carbon way. Hydroelectric, we have a long experience with. This is the biomass plant near Lockerbie. Again, sources of low or zero carbon electricity, which can be part of the solution. No one is the silver bullet. No one of these technologies will provide all the electricity we need. None of the things I'll talk about tonight are the solution. Perhaps geoengineering, you'll have to make your mind up when I go through the strategies. But for these are the solutions, and they have to be used in the round in terms of a box of solutions that taken together can help us avoid that 2 degrees of post-industrial warming. My favourite subject, the thing that I've worked on most over the last 15 years or so, are the non-CO2 greenhouse gases. So we think about carbon dioxide, CO2, as the greenhouse gas to worry about. And it's true in terms of human activities, it's the most important. But running rapidly behind it is methane and nitrous oxide, these two powerful greenhouse gases which are emitted by things like fossil fuel exploitation, by rice paddy cultivation, and by cows like Daisy here. She emits a lot of methane, not from the other end, but just from here. She actually burps methane out. And we know that the global population is probably going to reach over 9 billion by the middle of the century. So not only do we need a lot more energy, but we need a lot more rice, we need a lot more beef, we need a lot more dairy products. So these sources have got to be part of the solution. We've got to look at these sources of greenhouse gases, and for some of these, we can much more cheaply address them in terms of reducing their emissions than we can for carbon dioxide. So again, we need to look at more than one gas in terms of our solutions. The big one for government, for policymakers, the big kind of way you square the circle in terms of cutting emissions is obviously in demand side. You can put up your swanky low carbon power station with carbon capture and storage, but if the demand doubles as you halve the CO2 output per power station, then you aren't affecting the net emissions. You're still getting essentially the same amount of carbon dioxide emitted to the atmosphere. So part of the equation, a very important part of the equation, is addressing the demand side. We've got more people, like I say, on the planet by 2050, a growing population globally, who want lifestyles like most of us have. And so we need to look at the demand in terms of electricity demand, but also in terms of food, in terms of transportation, and see how that can be addressed. So from the calls for all of us to eat more homegrown food, through to Rajendra Pachauri's call for us to eat less beef in terms of the methane emissions. These demand-side approaches, again, some of them are, I guess, insignificant in terms of the impact they would have on global emissions. but as a suite of measures and as a change in, I guess, our society in terms of how much greenhouse gas we emit, they can play a very important role. Demand side, very important. The other circle I had on my initial figure of the carbon cycle was land use change. Now we know land use change has been a key player in terms of our role in driving changes in the atmosphere and carbon dioxide way before we got into burning a lot of fossil fuels. So we had the Enlightenment born in Scotland and a big increase through the Industrial Revolution of burning fossil fuels. But thousands of years before that, we were cultivating land, we were changing land use in terms of converting forests to agriculture, for instance, and inducing carbon losses to the atmosphere. So it's a key part of the whole in terms of how much greenhouse gas is in the atmosphere, but also these natural ecosystems, so the terrestrial ecosystems and the oceans, do us a hell of a favour. They really do. This graph here basically shows the annual emissions, the top line. So if you look at the blue thing, basically that's saying, yeah, we've emitted more greenhouse gas through human activities. But not all of that has stayed in the atmosphere. What we've seen over that same time, so since 1950 up to past 2000, is an expansion of what we call the sinks, the terrestrial ecosystems, the oceans, taking up more and more carbon dioxide from the atmosphere. We know that over that time period, between 40 and 50% of what we've emitted has been taken up by these sinks. So the oceans, terrestrial ecosystems, mainly the forests and the soils below them, have done a great job at buffering our impact on the atmosphere. Obviously, if we are to carry on relying on this, we need those sinks to carry on increasing or at least not decrease. And for the terrestrial ecosystems, for the forest, that really means we need to address deforestation. We need to make sure these sinks go on doing their job. The way we address that, the solutions, afforestation or reforestation, planting new trees, and RED. RED was one of the hot acronyms in Copenhagen. It stands for Reduced Emission from Deforestation and Degradation. It was recognition that if we're spending, I don't know, £150 in the UK to cut a tonne of CO2 from a power station using carbon capture and storage, for that £150, in terms of spending it on reducing emissions from deforestation, we could cut maybe 30, 50 tonnes of carbon dioxide. So in terms of a global response, it's a really cost-effective way of cutting emissions. It's difficult in terms of implementing it because actually going on the ground, making sure the investment gets to the people who need it and who will reduce deforestation is not as easy as it might sound. But it's a cornerstone in terms of climate policy. So in terms of the solutions, it's not just about energy, it's about the forest too. If we sum all these up, and this is again from the fourth assessment report, and this is, I think, a kind of good news figure if you can dig down into it. You look at all the sectors I've talked about. So we've got energy supply, transport, buildings, agriculture, forestry, waste, etc. And what this does is say, how much can we reduce emissions from these sectors and how much will it cost us? And what you can see is that it gets more expensive as we want to reduce more. But actually, if we look across these sectors, there are some really big reductions that can be made. Buildings stand out there. You know, the demand side I was talking about, increasing the energy efficiency of our built environment can get us great gains in terms of reduced emissions. And if you add these together, we've got what we need to avoid the 2 degrees post-industrial warming. We've got the tools, we know how to do it. We don't need to invent a brand new solution to solve the emissions problem we've got. We can do it through the techniques that I've summarised just before. So this is a good news story, apart from the fact that this is all potential rather than reality. And the challenge for policymakers is to make those happen and to make them happen at the least cost, so they're acceptable. I sometimes am cynical, particularly on an occasion like post-Copenhagen. I come away thinking, well, they've got all this information, you know, they're not acting on it, you know, we're really in a state where we need to forget about mitigation and just prepare for climate change in terms of adaptation. Investment should flow into that. And absolutely, there's an argument for if we don't mitigate enough, then we're going to have to adapt to more climate change, so investment is required by adaptation. But one of my biggest concerns, I suppose, and I suppose you could see it as some of these as silver bullets, is that if we don't mitigate climate change to the extent outlaid here, so big cuts in emissions, and if we don't have the investment or the ability to adapt to the climate change in terms of rapid climate change, then we've got this option called geoengineering. Now, for those of you who haven't heard about geoengineering, it's something which probably 5 or 10 years ago was kind of whispered in corridors as, I've got this great idea to tackle global warming, I'll paint everything white and reflect the sun's radiation. It was kind of almost a thing you would do after a couple of glasses of wine, is think about if you ruled the world, how you would engineer the climate. It's moved from that into serious consideration in terms of scientific consideration, but also in policy circles. If we get to the stage where we can't get a global agreement on emissions, we can't afford rapid climate change in terms of the impacts and the adaptation required, then geoengineering becomes quite attractive. What it is essentially terraforming. So it's originally used to describe, I guess, a kind of Star Trek approach of going to new worlds and changing them to an environment which is habitable for our species, so terraforming them, engineering their climate to be habitable. But now we use it in the context of our own planet and engineering its climate to essentially avoid rapid climate change. And it uses one of 3 main mechanisms for changing climate. These are to change how much energy the Earth receives at the top of the atmosphere. So engineer essentially how much energy the sun is giving us as a planet. The other mechanism is to change how much energy is reflected, so the albedo, either of the surface of the planet or even the atmosphere. And the third one is to engineer the greenhouse effect. So kind of what we've done in the past in terms of we've engineered an increase, an enhancement of the greenhouse effect through our carbon dioxide emissions. In the context of geoengineering, it's essentially doing the opposite, so taking out a lot of carbon dioxide from the atmosphere. So I'm going to give you some examples of all 3 of these. Keep an open mind. Some of them are, to be honest, still absolutely crackpot. Some of them are getting serious consideration, and I could have said 5 years ago, well, these will never happen, and it's kind of if the worst happens, we would never pull these out of the drawer. But I may live to eat my words on that. So the first one, change in energy input from the sun. That sounds pretty mad, but it's possible. And this is how you do it. Very big mirrors. So there's a point between Earth and the sun called the Lagrangian point, the L1 orbit, where we can put stuff in between us and the sun, and essentially it will stay in the same position relative to the Earth. So it can intercept the sun's energy. The calculations have been done on how much we would need to offset our emissions of carbon dioxide since the Industrial Revolution. In terms of mirrors, 3 million square kilometres of mirrors would do the job. That would be pretty good. Or we could just use dust. If we couldn't get our hands on that many mirrors, 2 billion tonnes of dust, again, that would intercept a lot of the sun's energy. It would be enough to offset the CO2, the extra radiative forcing here that we've got from our increase in CO2. There's a couple of downsides to this. One is if we carry on emitting CO2, then we would have to keep adding mirrors. So for every 2 parts per million, so that's the kind of increase we see each year in the atmospheric concentration, we'd have to put up about another 33,000 kilometres squared of mirrors. So it wouldn't be an instant fix, forget about it, but we could do it. The main downside, and you may have spotted this, is that putting that many mirrors, or certainly 2 billion tonnes of dust into space, is a pretty costly exercise. And in terms of the impact it might have on the global economy just to do it, but then on things like crop yields, variations in severe weather impacts from the fact that we're getting different amounts of energy input and we've got all these mirrors in the way, of the sun's energy. My solar panels, for instance, I would be suing whoever it is, Barack Obama, if he put up these mirrors. I'd say, look, I invested a lot of money in my solar panels and now it's dark all the time. You know, and I expect that in Scotland in the winter, but not in the summer. So, you know, in terms of an option, we know scientifically this is one of those ones which you would do after a couple of glasses of wine. We can do it, but cost-wise and essentially side effect-wise, this would be a very dangerous geoengineering solution, but it would probably work. The next option we've got is to say, okay, how about forgetting about intercepting the energy coming from the sun before it gets to the Earth, but what about the top of the atmosphere or in the stratosphere, so the upper atmosphere of the Earth? So one idea has been to release billions of reflective balloons into our upper atmosphere. Again, they would bounce a lot of the energy from the sun back into space. We would reduce the heating at the surface. That one, as far as I know, hasn't got past the kind of mad scientist level yet, but we know the mechanism would work. What has got past the mad scientist level are these last three. So one is to say, okay, we've got a lot of aircraft, a lot of them fly high up, they fly at the top of the troposphere or into the stratosphere, so 15 kilometres, 20, 30 kilometres up. If we got them to produce more particulates, basically dust, soot, things which, if we manipulated the fuel in the right way, they could make our atmosphere more reflective, increase its albedo, reflect more energy. We could use them as the delivery vehicles. That's got some traction. What's got much more traction, which is why it's got a little star, is to use that same mechanism in terms of particles, aerosols in the atmosphere, making it more reflective, to increase the albedo of the atmosphere and deliver it either by aeroplanes or by rockets or even by firing shells loaded with sulfur to produce these sulfate aerosols in the stratosphere. That's got a lot more behind it, and I'll show you why on the next slide. The other one I'll mention, increasing cloud albedo in the troposphere. This is something which has been born out of Australia and Edinburgh, actually, in terms of the great minds behind it. And again, in theory, it looks really good. In terms of side effects and more understanding, we need a lot. But let's have a look at this one, sulfate aerosols. Why do we think this could be the goer? This could be the geoengineering option. Well, because we know it works. And we know it works because of volcanoes. We know volcanoes all too well. If you fly in the last couple of years, then you probably had some disruption from them. We know they kick up a lot of dust. But what they also do, if a big eruption like Pinatubo here in 1991, is emit a lot of sulfur. Pinatubo, 20 teragrams. So that's an awful lot of sulfur. That's 20 million tons of sulfur being injected into the upper atmosphere because it's a really big volcanic eruption. What happened there was not just a lot of dust locally and people worrying about flying from A to B, but we saw the global average temperature drop by 0.4, 0.5 degrees centigrade for a couple of years. So we have an analogue, we have a precedent for injecting lots of sulfur into the stratosphere and it cooling the planet. And we can go back through essentially the geological record if we want to, so a lot further back than this, and look at how big volcanic eruptions which injected not just dust but particularly sulfur and sulfate aerosols have been able to cool the planet. So we could do the same. We've got mechanisms to deliver the sulfur to the atmosphere. It's been propounded even by Paul Crutzen, Nobel laureate for his work on the ozone layer. He said if things get too bad, this is probably the option that's least offensive, I guess, to the world. What we need for this, and this is another caveat to how successful it would be, is we'd need an injection of sulfur into the atmosphere, into the stratosphere, about every 4 to 8 years of the magnitude of Pinatubo. Because these sulfate aerosols aren't like carbon dioxide. They don't last for hundreds of years. They last for months, maybe years if you're lucky. So the cooling effect will be temporary. We keep having to put this stuff up. And if we stopped, and in the meantime had been increasing our carbon dioxide concentrations, then the heating would be very rapid indeed, as we see in terms of post-volcanic eruptions. So the sulfate aerosol geoengineering technique, that's the one to watch out for, because we know we could do it. We know it would have the kind of results we want on a global scale. Still, there would be big caveats in terms of acidifying the atmosphere. It's pretty big downside. We know that there'd be side effects in terms of likely changes in precipitation, potential crop losses, but it's probably the best game in town in terms of geoengineering at the current time. For those, particularly for the students doing this course, on your reading and on the web page for this talk, I've put up 2 reports, one by the Royal Society about geoengineering, assessing which options are most likely have some credibility to them, and another one looking at the costs. And from both of those, this technique seems to come out as the current favourite. Closer to Earth, and I talked about the Edinburgh involvement here. We've got whitening clouds. I get told off by meteorologists when I say whitening clouds, but essentially that's what it looks like to me, because what these mechanisms are all about is essentially seeding clouds with small particles, which mean they reflect more sunlight. They have a greater optical depth, they reflect more of the sun's energy. So all right, we've got the sun's energy coming right through the atmosphere, but at low level, if we have lots of these clouds and they're very white, they will reflect more of the energy. So one of the geoengineering suggestions is to say, why don't we manipulate these low-level clouds? And Stephen Salter, one of our professors from the engineering department here in Edinburgh, and colleagues, came up with this wonderful idea, inspired idea, to seed clouds with essentially particles of salt. So you would have these big boats emitting lots of salt particles, salt spray, into the lower atmosphere. That would seed clouds, make them whiter, reflect more energy. If you had enough of them, you can see here their estimate, 1,500 ships emitting about 1.4 billion tonnes of water per year would have a real impact in terms of warming. It's a lovely idea, and I remember Stephen coming into, I was working in the engineering department at the time when he was starting to come up with this idea. He came in with a whisk, and I was working on a big wave tank, and he said, oh, can I have 5 minutes? And started whisking, and the water started spraying up, and the more it sprayed, the happier he got, and then he disappeared again. And what he was doing was trying out different techniques to make the droplet size just right. And that's one of the limitations to this technique, is getting that droplet size just right to seed the clouds, to do it in the right place. And one of the criticisms from the Royal Society assessment was that this would be pretty effective on a local scale. You could definitely get the cooling, but could you actually get global cooling of the magnitude required to offset anthropogenic forcing through greenhouse gases? So it's a really neat idea, but I think Stephen would admit more research, more funding, I think he would admit, is required. I should say before I move on, I've got there and surface albedo, and I mentioned this idea of painting everything white. And we know that if we've got a whiter surface, we will reflect more of the sun's energy rather than absorb it, so we'll get less heating. So if we take our managed environment, all the buildings on the planet, all the fields, and we look at all the buildings being painted white, all the fields growing high albedo crops, so more reflective crops, whiter crops, then maybe that would be a way to engineer the climate to reduce the amount of energy absorbed and reduce global temperatures. The analysis of this indicates, no, it wouldn't. The extent we could manage in terms of our managed environment, the built environment, would be a tiny fraction in terms of negative forcing, in terms of the cooling required to offset the greenhouse gas forcing. But again, it's a neat idea, works really well if you've got very hot cities and you want to cool the local environment. So you want to cool buildings by making them more reflective, but on a global scale, doesn't seem to be a goer. Another suggestion which actually got to the commercial stage is to use those sinks I was talking about. I talked about the forest being really important for taking up carbon dioxide, but the oceans are even more important. They're the biggest natural sink for our carbon dioxide. And we know that a key process in terms of that CO2 uptake is the biological carbon cycle, the biological pump in the oceans. Algal growth and then algal death, and that algae being eaten by shrimps, crustacea, them crapping that algae out, and it's sinking down into the deep ocean and being locked away from the atmosphere for hundreds, thousands of years. So if we can accelerate that process, if we can make algae grow faster, lock up more carbon, and get that into deep sediments, the deep ocean, then that could help us geoengineer carbon dioxide in the atmosphere and so geoengineer the climate. So there were companies, there's a company called Planktos who are actually, I think you could buy shares in them. They were looking at doing this in terms of seeding the oceans with the stuff which the algae want. Most parts of the ocean, it's micronutrients like iron. Other parts of the oceans, it's nitrogen and phosphorus. But you can produce, like on the left here, really big algal blooms by giving them the fertilizer they need. In theory, that's great, and you can show that a lot of carbon is taken up by these blooms. The problem comes in this stuff, and how much gets down into the deep ocean. And the studies that have been done on these fertilization experiments indicate that most of that carbon is quickly recycled and emitted back to the atmosphere. Only about 1% in your best kind of experiments, best conditions, maybe 5% of the carbon actually is taken out of the atmosphere for a long time, so the kind of length of time we need it to be removed. Planktos, I think, went bust, and still we're looking at how algal blooms can be engineered and how they respond in terms of these micronutrients, but as a geoengineering technique, they're just not going to give us the carbon drawdown required. So what about on land? Well, this is one of, I thought this was a mad one until I read the Royal Society report, and this comes out as probably second place after sulfate aerosols, and this is artificial trees. Now, as someone who likes trees, I kind of think they do a pretty good job already, and improving on them seems, a bit arrogant as a species, but this, in theory, would work where you can't grow trees and you've got land which essentially is open to other uses, so you're not growing crops, or you can grow crops underneath, but the idea is that you have these structures with compounds in them, so things like amines, alkaline solutions, which will draw CO2, carbon dioxide out of the air, just like trees do when they photosynthesize. The idea with this is they are super trees, super CO2 absorbers, and once they've trapped that carbon dioxide, that can be drawn out, it can be stored, so using carbon capture and storage techniques, and then you would essentially return the active solution again, sodium hydroxide, whatever, alkaline solution, back to these artificial trees, and they would keep sapping out carbon dioxide from the atmosphere. We would need an awful lot of them, and in terms of the efficiencies that have been shown for these, it would be a global effort to reduce carbon dioxide concentrations again to a level where it will have a global impact. But it's got serious consideration in terms of scientific circles and somewhat in terms of policy and business circles. Very quickly, just to mention, and it feels like I'm kind of bigging up Edinburgh research, but this is another area where we work a lot, some of my colleagues, in this area of biochar. If you hadn't heard about this stuff, and they'll tell me off for this, but I think it's just charcoal, but it's how you use the charcoal. It's essentially carbon which, if you put it in the soil, will stay there, or a large proportion of the carbon in it will stay there for many, many years, hundreds, potentially thousands of years. And the idea is that we can produce this biochar, this recalcitrant carbon, through burning biomass. We can get energy from it, but instead of all the burnt biomass essentially being converted to energy and CO2, we take a portion as this recalcitrant carbon, put it into soil. It's been shown to increase crop production rates, and it will stay there for potentially thousands of years. If we do this on a large enough scale, then we're looking at putting a huge amount of carbon into the soil, and it's staying there for a long period, a scale which would effectively offset our increase in carbon dioxide emissions to the extent of about 1 billion tonnes of carbon per year if it was really rolled out on a huge scale. It's still really at the research stage. There are many uncertainties for all of these geoengineering techniques I've mentioned. There are many potential negative side effects, and there's a lot of research to be done on all of them before we roll them out. But obviously the pressure of maybe we need to use these is starting to increase. And finally, and this is my mad scientist moment. So this is me not being too mad there, but one of my hopes is that microbiology and our knowledge of microorganisms, algae, bacteria, the stuff I worked on in the Southern Ocean, as David mentioned, that our knowledge of those can help us, in this case, produce biofuels which don't impinge on food production, don't impinge on land use, so things like algae producing fuel, so offsetting fossil fuels. All the ultimate mad scientist stuff is essentially developing through genetic modification, all through our understanding of various bacteria which use things like methane, which is this important greenhouse gas, to manufacture a superbug which will essentially strip out a lot of the methane from the atmosphere. Now this is the kind of, I suppose, if you gave me enough money, I probably would turn the world to grey goo, like Prince Charles worries about with nanotechnology. I'd probably do it with superbugs, but I'd have a damn good go at tackling greenhouse gas emissions on the way. So I want to sum up really by saying what we're doing as a community of climate change scientists, greenhouse gas scientists, the kind of areas we work on. Well, a lot of our work is on the feedbacks and uncertainties. So those sinks, the forests and the oceans, will they go on taking up our carbon dioxide, or will they start to falter? Big question in our projections. We're getting better at projecting impacts. So knowing for a certain amount of climate change or sea level rise, what impact that might have and what we need to do to adapt to it. We're getting better, particularly with satellites, at monitoring. So we can now look at how much deforestation there is, which bits of investment are working in terms of reducing deforestation, which areas aren't responding. We've got myriad technologies. I've talked about a lot of the technologies we're familiar with for tackling emissions, for tackling adaptation. They're new and old. Emily here, so Emily Cummings is one of my heroes, and she was a student taking a gap year. And she went to sub-Saharan Africa, and she went around lots of villages. And the background to Emily, you can see her there, she's in her granddad's workshop. And I think she probably drove him mad, because throughout her childhood, she was always in there tinkering with things, making things. She had that kind of mind. She went to these villages in sub-Saharan Africa, and she saw that one of the key issues for all of the communities was food spoilage. Food would go off very quickly. They had no mains electricity, so no access to fridges and refrigeration. She came back, she probably kicked her granddad out for a couple of weeks, and she came up with this, which is a solar fridge. Really simple design. It's got one jacket, one cylinder inside another cylinder. You add a liquid to the outside, and through evaporative cooling, you cool what's inside the central cylinder. This is something which doesn't need electricity, hugely effective, and it's now used in the villages that she visited. It's that kind of innovation, it's that kind of mind which makes me hugely optimistic about both adaptation and mitigation. We can do this as a species, absolutely. From my point of view, though, what I'll do is I'll write more reports rather than come up with things like this. I'm not clever enough for that. Hopefully we'll come up with improved solutions like Emily's. But by itself, that innovation isn't enough. I started off being a bit despondent about Copenhagen. But we do need political leadership. We need a market signal in terms of tackling climate change. That is part of the solution to deliver all of the mitigation, adaptation that I've outlined. So what we need, well, a global climate deal in Cancun or South Africa, which is the 2011 big climate conference of the UN. Or we need national solutions. Scotland, the UK have the world leading legislation in terms of targets to cut emissions. They've got the tools to do it in terms of natural resources, so can they show the world? Maybe we need just multinational agreements or bilateral agreements. So China and America saying, look, we're the biggest emitters, we'll tackle it, everyone else, just get on with what you're doing. Or if we fail in terms of all those options, we don't get the political lead for mitigation, do we open Pandora's box, geoengineering? And at the moment, if we do, there's some big uncertainties that we're facing. I want to finish now really by, like I say, talking about the thing which gives me a skip in my step every morning. The main reason I'm hugely optimistic about our ability to innovate and tackle climate change, and it's my own students, the carbon management students. So I'll just put this video on and keep my fingers crossed that it works. Like I say, it's from Copenhagen in December last year.
We are now faced with a decision that will impact future generations, and Copenhagen is the arena for this decision. Meeting here at COP15, we believe the world can be united. This is not true, and it's too late to make a difference. My children will tell me that I am responsible. I know that I have my priorities straight, because material goods are more important than my children's future. I tell you this, we had the opportunity to avoid dangerous climate change, but this is no longer true. This is a society without vision. Experts tell me many will be lost in great floods and droughts. I do not concede that I live in a world of my own making. In the future, global inequality will be the norm. No longer can it be said that my peers and I care about this earth. It will be evident my generation lacks leadership. It is foolish to presume that there is hope. And all of this will come true unless we choose to reverse it. There is hope. It is foolish to presume my generation lacks leadership. It will be evident that my peers and I care about this earth. No longer can it be said that global inequality will be the norm. In the future, I will live in a world of my own making. I do not concede that many will be lost in great floods and droughts. Experts tell me this is a society without vision, but this is no longer true. We have the opportunity to avoid dangerous climate change. I tell you this, my children's future is more important than material goods. I have my priorities straight because I know that I am responsible. My children will tell me it's too late to make a difference. This is not true, and the world can be united. We believe, meeting here at COP15. We, the Carbon Management Society, hope to see today's leaders come together to learn from past lessons and achieve a global binding agreement.
Thank you.
Thank you, Dave, very much. Gives me a lump in the throat whenever I see that, I must say.
Me too.
Ladies and gentlemen, I'd like to open it to you so we can have a conversation. Dave's laid out quite a number of practical technical measures that are being explored here at the university and elsewhere. What do you think? Is it possible that we can turn that supertanker? And are there any particular questions you want to ask Dave about that you can see if you can trip him up, tease him?
Hand up there, there's one there as well.
Was it at the back?
Yeah, right up at the back.
Okay, fine.
What's the chance of instituting an effective carbon tax within our lifetimes?
For us in the UK, very likely indeed, I'd say. A carbon tax, well, I suppose effective carbon tax is the key thing. A carbon tax we're likely to see. So in terms of high emitting aspects of our lifestyles, we already kind of pay it in terms of the European emissions trading scheme and a hard wiring of costs through that for us in Europe. But I think in terms of the acceptability of a carbon market, say in the US, that doesn't look likely in the near term, and carbon taxes look like they would be the interim measure, I suppose, where you're focusing on certain behaviours, like potentially flying, like potentially driving big cars, to change behaviour. But it's a very blunt instrument, a tax. But as we know, in this economically constrained time, more taxes and selling them in an acceptable way is something that all chancellors are probably looking at, and so I wouldn't be surprised if we see more carbon taxes. The key question for me would be, are they really effective at cutting carbon, or are they just filling the treasury with more money? And that's a question which probably one of my economist colleagues can answer.
Hi, good evening. Thank you very much. It's been fascinating, also quite scary. The sort of thing that worries me is if we put 2 billion tonnes of dust out at the ground point and then, for example, transition at the university manages to get us to stop emitting carbon dioxide on the Earth, we'll have another ice age before we can get out and hoover up the dust. Are you saying that the human race now has to take responsibility for knowing what the right temperature of the atmosphere or the planet is, and we'll have to make it happen, and we can no longer rely on nature to do it? And if we don't get it right and take responsibility for this ourselves, we risk our own survival.
I think, and it comes down a little bit to how in awe I am of our species. I don't think our survival of our species is actually at risk here. I think what's at risk are the lives of millions, potentially billions of people through the coming centuries from climate change or geoengineering. We know that with the projections from the IPCC, the Intergovernmental Panel on Climate Change, that climate change could be somewhere between 2 to 4.5, 5 degrees centigrade temperature increase during this century. Now what that means for a lot of us, if it's 2 degrees, UK probably handle it. You know, most of us, we won't see a huge direct impact on our lives, but it will still affect many millions of people elsewhere in the world who are already experiencing climate change. So the choice, I suppose, in front of policymakers and society is what extent of climate change, what extent of warming are we prepared to put up with? How much money should we put into adaptation? How much into mitigation? How much grief are we willing to pay for now, or how much should we put off to the future? Geoengineering kind of scares me, because if we present these options as kind of, you know, as a suite of options, you can impose a carbon tax, you can make people, your electorate, really cross with you, you can essentially put more cost on the developed world to tackle this problem, or you can solve it in a couple of months by putting 2 billion tonnes of dust up. Then, you know, in that kind of simple view, there's a real danger that geoengineering is adopted as a quick solution, and actually we end up paying, well, future generations pay a much bigger kind of payment to that in terms of the impacts of geoengineering for generations to come. And one of the things I think I said in terms of, for one of the geoengineering strategies, is you can cool the planet, but the CO2 concentrations, if they're still going up, will kick in terms of enhanced warming as soon as you remove that cooling influence of, say, the sulfate aerosols. And you can envisage, and it's probably been done in, you know, in Star Trek or something like that, where we lock ourselves into a situation where we cannot stop emitting sulfate aerosol, because if we did, the warming would be so rapid over a short period of time that the impacts of climate change would be something we couldn't adapt to at all. So we could lock ourselves into essentially clouding the sun. I think it's been done in Highlander, actually, that one, the film.
Do I need the microphone? Or can I
Yeah, best if you can.
Thank you. One of the things that's never mentioned in any of these meetings is the option of digging up less fossil fuel, or digging it up more slowly, and in fact taxing at that level. Even Nick Stern's report on the costs of mitigation failed to say anything, as far as I know, about what are the economic impacts of actually digging up less coal and oil and gas. I wonder whether you'd like to comment on that, because it seems to me fundamental. It's also the simplest point at which you can impose a tax or a rationing scheme or any other political thing you want to do, and it's the point at which you could get international agreement if one presented it fairly.
Okay, so it sounds brilliant, and it sounds like essentially you're addressing it at the heart. You know, you've got your fossil fuel, coal reserves, we put a tax on that, and so less of it is exploited. In terms of getting a global agreement, I think it would be very unlikely ever to happen. And one of the main reasons for that is, as I talked about, that still we have large reserves of coal, enough to raise global temperatures massively from what they are now, increase carbon dioxide concentrations, and it's a great source of energy. And when you've got many billions of people wanting to consume more, to have lives, more comfortable lives like ours, you know, essentially you're proposing to big growing economies like China and India that they must take an alternative route and not exploit coal for the greater good. whereas we've had our fun with our fossil fuel, but they're not allowed to have theirs. And so in terms of, I agree with you that it needs to be addressed, and we can't afford for all that carbon that's still in the Earth's crust and still available to be emitted to the atmosphere. But the mechanism you do that, whether a global carbon tax on coal extraction would be acceptable to what are now the main superpowers, and that was clear in Copenhagen. Barack Obama is no longer the superpower. It was actually China were calling the shots there. To make it acceptable to them, you would have to give them a real alternative, a real leapfrog in terms of technology. So say, okay, you know, we are going to provide you with technology transfer in terms of massive investment in wind, in hydro, in biomass, so that they can still make people's lives better without exploiting that coal, and that's expensive and that's tricky.
Hello, David? Benedict Robinson. Do you think that 1 teraton as a cap to contribute to negative global warming temperatures is right? And if so, how do you pose or foresee that we can quantitatively divide that up? And my second question is that how do you pose to integrate climate policies for more economically developed countries like the West, as well as less economically developed countries like China and India in terms of carbon reduction targets, given that countries like China and India need to be allowed to develop just like we have?
Yeah. Okay, I'll try and link them together. So in terms of avoiding 2 degrees of post-industrial warming, the climate sensitivity has some uncertainty attached with it, and Gabby hopefully mentioned that last week. But in terms of reducing emissions, we're looking at global emissions having to reduce by 50%, so by half, by 2050. So for developed nations like ours, that means an 85% cut over that period. Massive cut, but that's the kind of cut that we've got in our legislation in Scotland and the UK. So I think that is achievable in terms of the solutions that I've outlined tonight. I think we can make that kind of cut. It's going to be really painful, and it's how we share the pain, which kind of comes into the second part of your question. So if we're going to allow economic growth, and there needs to be economic growth in the developing world, in the transition economies like China and India, for every extra tonne they emit as part of their development, we have to essentially cut our emissions. So the key question is going to be, and still is at the negotiations, and if I had an answer for this, I guess I would have been in Tianjin last week, and I would be opening the champagne if I had the answer, is how do you get that balance? How do you say, look, for these big economies, China and India, going back to them, big emitters, they do need to develop. They need to bring people out of poverty, as Paul talked about in the first of these talks in this series. But that very progress, that very economic development itself is threatened in those nations by climate change if it's unrestricted. So what we need is big cuts in the West, but we do need China and India to be part of it and to make commitments in terms of how much their emissions will rise and then where they will stabilise. And for them to make those commitments, that needs a big commitment from us, the developed world nations, for technology transfer, for a level playing field in terms of markets, essentially to allow them to not make the mistakes we made. So Cancun probably won't deliver this in terms of a global agreement which addresses that. But there have been moves in the right direction. There's a consensus that money needs to go into adaptation rapidly, much more. We're committed to a certain amount of climate change. We need to address that quickly. For South Africa, that's probably the conference that I'm looking at in terms of real potential from, so you know, we're over a year away from that, for a global agreement which does address the concerns of both sides, essentially the rich countries, US in particular, and China and India, and gets a consensus where ultimately they're saying, look, if we leave it to the other, if we don't get a global agreement, we can grow quickly now, but we'll be hammered in the future in terms of our development. So it's that, it comes down to we're all in it together.
I wondered if I can take a chair's privilege to compliment your talk about pain and that it's going to be really hard and so on, with the story of how we're getting light here and heat in this building now. And this is from the power station, which is at the back of the old medical school, George Square Energy Centre. That's powered by North Sea gas. It's not a power station from Kirkensey or Longannet. And it's that, along with the two other ones at King's Buildings and Pollock Halls, are generating a £1.5 million a year saving for the university, have paid off the whole £7 million loan, all because we had the vision, senior management here, the Director of Finance and others, had the vision to invest £12 million in these 3 power stations. So we're doing it more efficiently. You may remember the graph of how power production works. The right-hand one, most, is up to 80% efficient, as opposed to in the 30% efficiency. Now that took investment, and I think that's one of the other things that's necessary. It's very, very clear. But we're benefiting from that because we've got new low-temperature distribution heating and so on. So I think I'll chip in that. I don't know what you feel about that.
I think
and then we'll come
I've got a guilt about my solar panels in that I got them installed this year, a big array of electricity producing panels on my house. Great in terms of they save a couple of tons of carbon a year, but they're a brilliant investment. They make me money because of a feed-in tariff, so there's been basically legislation which means you get paid for what you produce. Now I love that, and it's a good incentive. 6,000 people across the UK have done it. The pain comes in the fact that all of you, as electricity users, get that, essentially that check that they send me, that price of that passed on to your bill. And so the pain is essentially spread by everyone who's not getting the feed-in tariff. And that is something where I do struggle in terms of where we've got policy trying to engage us as individuals and trying to get us to be part of cutting emissions. But in terms of where that investment comes from, if it's from each other, then I think there's only so far we can go. And obviously for what our government's doing in terms of cutting emissions, a lot of investment has to go into what they call the green economy, in terms of investment in green jobs, in renewables, in research into carbon capture and storage even, rather than it always relying on it on kind of Peter paying Paul.
Take another question. And then was it you?
Just wanted to bring it back to a slightly more local view, I suppose, looking at it from the point of view of I'm struggling Scottish hill farmer. If you look at it, I was wondering what you thought the likelihood of overcoming, I don't know how to describe it, whether it's sort of the innate NIMBYism or hypocrisy of the Western world, but looking at it in Britain in particular, that they will quite happily go around, they will turn their lights off and try and lower their energy emissions on that side, and yet they will still demand raspberries in the middle of February, they will still expect their couch to be straight. All the stories about Daily Mail, that it's European legislation, it's not. It's the fact that, I'd get into trouble for the phrase, but the great British housewife simply won't buy bent carrots. She doesn't know what to do with the internals of a chicken or whatever it might be. Yeah. And I wondered what you thought the likelihood of changing that is. That no matter what anyone does, food miles is a great contribution. If people could look at it a bit more locally and use what we have at the moment, that would benefit everybody.
Again, and you'll be familiar with this, we all are, that we've got some brilliant examples of community initiatives, transition towns, groups who essentially are fed up with what the supermarkets are prescribing they buy, and basically talking to farmers and saying, well, why don't we go direct? Why don't we look at not just, changing our behaviours, so not, buying strawberries in the middle of winter, but actually looking at all the wastage we get from apples is a good example. The amount of apples wasted because they're not that perfect, unblemished surface. And there is a real upsurge in terms, certainly my local community, and you see it all over the UK, in essentially communities reclaiming where they get their food from and their understanding of it, and wanting to essentially invest in the local community and support that, and support British farming at the national level. So I see some real positives there, and the supermarkets aren't stupid. As soon as they see enough of that, then they'll get in on the act. So Co-op, for instance, are a very good supermarket for taking that kind of testing the water and saying, well, is there a way we can change what we provide in our outlets to fit with that ethic? So as consumers, they certainly don't see us as passive. Obviously, they rely on us. And I think once you get enough groundswell and they see their bottom line potentially be affected like we've seen with fair trade, organic before it, they'll get in on the act and things will change. So I think, you know, again, there are reasons to be positive.
And was there somebody in this part here had a hand up? Otherwise, in the grey, just there.
Hey, I'm just wondering how much of this you feel will be a top-down versus a bottom-up process. You've spoken about Copenhagen and how that was kind of a failure. I mean, an elected official probably won't want to be imposing taxes because they're up for re-election in 4 years' time. It's not going to be, or less, it's not going to be a popular move. Versus things like you were just discussing, the local initiatives whereby kind of changing the mindset of people locally and of small scale communities feeling like they can do something themselves. Do you really, I mean, is there a cause for believing that there might be top-down imposition before the bottom-up comes?
I think, I mean, the top-down influence you see in things like the Climate Challenge Fund in Scotland, which has actually brought a lot of these groups into being. So the top-down isn't just from direct kind of stick, it's carrot, to use, to pardon the pun, in terms of already what we're seeing in terms of government influencing emissions. I think ultimately, on a global scale and on a national scale, in terms of the cuts that we've got in train, that we've got to meet in terms of targets, top-down is where it's going to come in terms of the stick for the markets and the carrot for the markets, and for us as consumers as well. We will see, I think, sticks like carbon taxes, but we may also see carrots in terms of feed-in tariffs. So ultimately, I've made I guess I had a road to Damascus moment on this. I believed always that all we needed to do on climate change was for everyone to be aware of the risk of unmitigated climate change, for education to be the be-all and end-all, and that would be it. My students actually have opened my eyes to the fact that we haven't kind of got enough time for that to feed through. The new generation, the kids, know more about climate change than any of us ever did, and in terms of resource efficiency, etc. But for the cuts required, we need serious top-down action. And how that's facilitated is for all of us to understand. So if they have a carbon tax, we need to question, is it effective? And then if it is an effective tax on carbon with an end point, which is to reduce emissions, then it can be more acceptable potentially to a populace who understands climate change. So it's as usual, it's kind of both.
Now, maybe just a last couple of questions, and we'll take them both together. That one there, and then one at the back.
Excuse me,
And then I'll be wrapping
can't talk.
up.
I have a lot of questions, but I'm not going to ask. I'm just going to ask just one, which is related to the last statement you made. When is it okay for us to have the audacity to decide for the world to go geoengineering, even to the extent of pushing the big red button? If it's a top-down approach, do we have the right to push that big red button?
No.
Okay. At the back there was just one.
I will.
I'm not sure that's what you said.
No. When you say us, you mean the UK government? The whole world agreeing?
Us in the West because we know better.
No.
I read recently that none of the candidates for the Republican nominations in America actually believe in anthropogenic climate change. Do you think we've got a political time limit on this? And if so, how do you combat the drop in belief in anthropogenic climate change?
In terms of belief or otherwise in anthropogenic climate change in the US, obviously we saw a drop in, I guess, public trust in science generally after East Anglia, and the failure of Copenhagen actually had a big impact. What you see from those senators or representatives in the US, the same in the UK, around the world, is even the ones who say, I don't believe in anthropogenic climate change, if you say to them, look, this market's going to affect your electorate, essentially you can get more jobs or you'll get this tax, then they'll have something to say about it. And what we're seeing across the world actually, so Australia's a good example, is as soon as you're in a position where you've got the market signal, the legislation which is driving forward change, so Obama's doing the same in the US, then what their opinions are about the proof of anthropogenic climate change or natural kind of doesn't really matter in terms of as long as they react to that policy. So if Barack Obama was still George W. Bush and still said, right, our position on climate change is it's all natural, we don't need to do anything, I'd be worried. But their administration has recognised that the evidence for anthropogenic climate change being important is overwhelming, and that they do need to do something, the market needs to react. And so the Republicans, I guess if they got back into power, I don't know, Sarah Palin being president would be fairly disastrous for global climate policy. But at the moment, it's a pretty positive situation in Australia, in Europe, even in China. We've got real political backing for action on climate change. It's just how to make it work so everyone's happy. And we're never going to get to a stage where everyone's happy with the global solution.
Dave, thank you very much indeed for your presentation this evening. Thank you.
You're welcome.
This production is copyright the University of Edinburgh.